your call.
So, hi everyone again. My presentation was about the effect of cyclosporin A on endothelial cells, and I talked also about some effect of extracellular vesicle to inhibit this toxicity. So they were mostly, and I was named by ESR number 3. So I would be happy to hear your comments or questions.
Just having a look to see if I see anybody raising their hands. Martin Leonard has a question.
Zara, I just wanted to ask you from your work on cyclosporin, did you think that you found anything novel in terms of the mechanisms of cyclosporin toxicity? Because I think there's multiple theories still, I think, ongoing with respect to different tissue, but also different cellular mechanisms of toxicity. What do you think, if anything, was new that you found?
Yeah, thanks for a nice question, Martin. So as I also tried to tell in my presentation, that we try to find the exact mechanism of cyclosporin A toxicity. So our aim was to get closer to the AOP development. We're talking about some key event relationships. So for example, one of the key event relationships that we could somehow find it out was about the ATP synthesis after mitochondrial dysfunction. So for example, when the transition pores are being closed and then RS cannot go out of the mitochondria, so ATP synthesis is increased, and then its effect and direct effect on the angiogenesis, because we know that if RS goes out of the mitochondria, then it activates the VEGF receptor signaling pathway, especially VEGF receptor 2, and then goes to nucleus to activate the transcription factors of angiogenesis, that we also see some of those transcription factors in our TempoSec data.
Thanks very much, Martin. Good answer, Zara. Zara, you should have a discussion. You should have a discussion with me and Martin and Giovanni later on when we're having a drink. We'll have a breakout room, because I just sparked an idea in my head now. Does anybody else have a question? Baz Glauber, please.
Hello, Sarah.
Hi.
Nice work. I have a question about the different types of endothelial cells that we have in the body. How close is your cell type with regard to, let's say, the cynocidal cells in the liver?
Yeah. So,
or any other organ?
Yeah, nice question. The thing was that in these times of the project, actually, we were not focusing on the different phenotypes of endothelial cells. So we knew that we could, for example, have the fenestrated or unfenestrated or tight junctions endothelial cells based on which organs they have functional. So by now, I cannot really say if the endothelial cells that we derive from iPS cells are close to the kidney endothelial cells or kidney vascular system, or any organ-specific vascular system. So I just can say that we have this model for the in vitro testing of the endothelial cells. So, but for now, for the time being, I cannot really say if it's any organ-specific cells.
That's a very good answer. Baz, you can have one more if you wish. Go ahead, Baz. Go ahead.
In conclusion, sorry, I forgot what I wanted to say. If you want to have, let's say, differentiated cells in different organs, you probably are not able now to use them in a organ on a chip model to mimic what's happening, for instance, in the lungs or whatever.
Yeah, but the thing to be.
I would like to add something to this.
No, I'm afraid I'm the moderator, and you're not allowed to answer something to this. Sarah will answer her own question. Sarah, go ahead.
Okay, so the thing is that I think that for having a differentiate organ-specific endothelial cells, we need somehow to co-culture them together. So to be able to have them organ and a chip, I can still recommend these cells, but I would strongly recommend to do a co-culture with some of the progenitors of that organ-specific cells.
I agree.
Yeah, very good. I think
Sandra has a question.
So who?
Sandra, but I need to see your video to spotlight her.
Well, we heard Sandra. Sandra had a lot of questions already, Sandra, so forgive me. Ellen, I think, had a question.
Okay, Ellen.
I will just on Slack, Sandra. Thanks a lot. Or Pat. Thank you.
So you work with the SBAT3 cells, and I know a lot of the other ESRs work with the SBAT2 cells. Is there a specific reason for that? And
well, not
just to clarify the question, just to clarify the question for everybody else, it just means these are two different donors, okay? So it's a donor-specific question. Sarah, take your time to answer that question. It's a good one.
Yeah. So honestly, I don't have any scientific answer to your question, Ellen. The thing was that I started my work with SBAT3 cells and differentiated them and started the cytotox data. In parallel, we did the differentiation also with SBAT2 cells, which worked, but due to the timing, so we decided to stick to one iPS-derived cell line and also primary cell line, which are Huvectert cells. But from the information I have from the differentiation and some of the cytotox data, for example, for cyclosporin A, I cannot say there was a real difference between these two cell lines, and that's why we selected SBAT3 cells.
okay.
Thank you. We're going to move on to Susanna now. Sorry, Susanna, if you weren't expecting that, but Susanna, could you just say the title of your talk?
Part of my talk, it's about in vitro and in vivo biokinetics. Yeah, so I focus mainly on the review and a specific example of quantitative in vitro and in vivo extrapolation for amiodarone, focusing especially on the brain.
Thank you. So is there any questions to Susanna about biokinetics or anything related? Nicoletta, please go ahead.
I enjoyed a lot your presentation, Susanna. And what I want to ask is about the modeling part. Did you code in R? What package you used? And also, did I understand correctly that the first model in vitro is kind of a preliminary type of analysis in order to get into PBPK, or was it like two independently type of models?
Yeah, so I modeled in R. In terms of packages, I use very basic packages. So just a package to solve differential equations. There are packages to do PBK, for example, and I'm sure they work fine. But I do think that the problem then they will kind of be like a black box in the sense that you don't know exactly some details, right? So I think I felt like for myself, because I want to change the structure and to understand how my assumptions impacted the model, I would prefer to actually develop the model from root. I think the packages usually are good if you want to do like a generic PBK and your compound is not very difficult. And on the other one, yeah, we saw that it has very specific behavior. So that was the thing. And then the two models, so they are different. I mean, they both are constituted by differential equations, and eventually I might be able to extrapolate, for example, the constant of absorption, desorption into tissue from in vitro to in vivo. At least I can compare it. But the models are separate in the sense that the compartments are separate, right? So one is to understand the kinetics in vitro. So in this case, in Carolina's model, there's the medium, there's plastic, and there's the cells, and then there's a repeated exposure. And what happens, so whenever she changes the medium, it means medium goes back to the same, to the nominal concentration, but there's still chemical in plastic and then the cells. And so that keeps accumulating. And this is actually what happens also in vivo for repeated exposure.
Thanks, Susanna. Is there any other questions? I'm just looking through faces. I don't see anybody's hand up. So if that's the case, I'm going to ask a question. So you hear a lot of terms for this. This is a cheeky question, obviously, for this thing of what you do. So you hear pharmacokinetics, toxicokinetics, and I heard one man once call it biokinetics, but he only ever said it one time. It's not like he repeated it over and over again. What's your feeling on that?
That's actually quite complicated, to be honest. And we had a lot of that issue during the review because there were several co-authors and they did not agree on what that means. But what I feel, so pharmacokinetics, it's first mostly focused more on in vivo, and it's not just toxicology, right? It can also be your pharmaceutical targets. your therapeutic target, I mean. So it's just, of course, like structure-wise, it might be similar. You just want to know how much chemical is bioavailable, but one is with the endpoint to know the concentration that causes toxicity, and the other one is to know concentrations that causes therapy. And that would be between toxicokinetics and pharmacokinetics. I'm guessing biokinetics then is like a bigger umbrella for it. And it also includes exactly like the in vitro ones, I would say, because to do, say, pharmacokinetics for in vitro maybe doesn't make so much sense. Anyway,
I think you answered it well. But let's say, Baz, just say, is it right or not? Raise your hand, Baz, if it's correct answer. Yes, very good. So if Baz said it was the right answer. The umbrella thing, I think, was interesting. I like that. Any more questions? Anna, are you raising your hand or just touching your glasses? Well, now you're raising your hand, and we can't hear you, so
there was pressure.
Who had a question? That's strange that nobody has a question after all of the interactions with the kinetics. It's difficult for me to think of one on the spot because I'm trying to see if anybody else has one. Let me see.
I can ask something related. I understood that you used the nominal concentration. Do you have also some results related with measured values for amiodarone? What would you guess that the real concentration would be?
Yes, no, I do have. So that's the point. So we have the data from Carolina for the kinetics, and what we have is, okay, first we have the nominal. In this case, actually, the nominal is what you calculate you will have. And then we also always have measurements of the dosing solution. So we actually know sometimes because if there's a little error, or maybe sometimes you lose a bit of amiodarone before. So we already have also that concentration. And then we measure it in time and in cells and medium. So then there's also one of the analyses was to understand actually by looking into different dosimetrics. So if you have your maximum concentration in vitro or your area under the curve of medium, like which one actually predicts better the toxicity? Because Carolina, in this case, she has a repeated explosion. She has curves those response for cytotoxicity in different time points. And then so is to see if we can actually understand which dosimetric better represent all these time points in terms of toxicity, because that's the one we actually, it's more useful to extrapolate between people.
No, that's fine, Susanna. You did very well. Very good answer. Now I lost track a little bit. So who wants to go next? Ivo, well, she wants to go next to you. Oh no, somebody spotlighted you. Okay, Ivo, you have 5 minutes. Now I want you to just say the title of your talk, and then it might remind people.
Well, the title of my talk is Development of an iPSC-derived airway at an air-liquid interface and Application for Toxicology and SARS-CoV-2 testing.
Okay, does anybody have a question for Ivo? Martin Leonard, obviously. Yeah, Martin.
Hi, Ivo. Just maybe you could just give us your opinion on how you could further improve your model, because you showed some level of characterization of the cells, the area epithelial cells, yeah, I'm just curious as to how you think the differentiation could be improved, the longevity of the cultures could be improved, how stable they are, working with this model for the length of time you did. I'm sure you have, lots more you want to do. Maybe you could just give us an insight into your thoughts on that.
For me, the main improvement would be a better purity of the cells that are plated on the insert. And to improve this, there are different ways. And one of them is to sort for basal specific markers. So you can use still my method with 3T3s and then sort and then plate. And this is something that has been published recently. There's a group that did this kind of experiment, and the end result of the construct that they get is much closer to primary models. But then again, there's other ways you can improve it. For example, you can add maybe other cell types like vascular cell types on the bottom of the insert, or fibroblasts co-culture with other cell types. You can play on the extracellular matrix that you're putting, because I played on matrigel. Perhaps collagen would be a better option. There are many things, to be honest, that can be optimized and improved. This is still early days. Like I've been alone working on this for 3 years. So there's plenty of things that can be improved, optimized, and yeah.
No, that's a good answer, Ivo. Thanks, Martin. Martin, if you have a second question, you keep it for a second. But does anybody else have a question? Don't see anybody's hand up. I don't want to put you on the spot, Martin, because if you don't have, that's okay. Do you have one?
Yeah, I was just wondering. I think it probably applies to everybody working with these iPSC models. I'm just curious about how it translates, to, you have an embryonic type cell, and it obviously takes time for cells to mature, and how do you consider the cultures that you have as representative of a stage of life within within an in vitro system that could be applicable? Are they more embryonic, and how do you think that may impact the toxicological interpretations that you might when you use these models further down the line?
Well, at the moment, iPSC models are still immature compared to primary models, and that is because...
Ivo, just talk about your model, because that's not true for all our models. So your model.
Okay, in my model, I would say that it's slightly less mature than the primary, because the primary cells were inside the body and they developed in there, and it's at the perfect conditions. Whereas the iPSC had to be reprogrammed, so you made already epigenetic modifications on it. What matters is not that it's completely perfect. What matters is that you can see the things that are necessary to make the prediction. And when I did the testing on both the primary and the iPSC model, we could see that very similar toxicological pathways are being activated when the same amount of concentration for the chemical is tested. So if you can still use it for the question that you're asking, I think it's good. And of course, it will only improve in the future and become as close as possible to in vivo. Perhaps it would become even better than the primary.
Yeah.
Good answer, Ivo. Is there one more question? Christian has a question. This will be the last question for you, Ivo.
Hi, Ivo. For the work you did with COVID, so from what I understood, you managed to infect yourselves with COVID. And did you play with this further in terms of exploring what happens if you treat it with some chemical? If yes, how many chemicals, which chemicals? If no, do you plan to?
So what we did was, I didn't include it in the presentation, but we measured the inflammatory cytokine secretion from the basal media on the bottom, and we found that there's increased secretion of the main interleukins, which are also found to be involved in the cytokine storms due to the COVID in vivo. So that was quite interesting. And now what we're trying is to treat the cells with compounds for 1 hour, and then infect them with the virus and see if we can reduce the amount of inflammatory cytokines, for example. Also look at maybe on a single cell level, identify which cell types are the ones that are being affected by the virus the most. And we'll see. It's still preliminary data, but it's quite exciting to see this happen.
Thank you very much, Ivo. Thank you, Christian. We'll go back to the room. Who's the next to you, sir? Somebody's on the...
It's Christian, but Walter had a question.
I'm sorry, Walter, you'll have to ask in a Slack or something, or in one of the breakout sessions, okay?
Christian, I lost you. He's here. Yeah.
So Christian, as same procedure as always, if you give the title of your talk, and then we'll do the questions. Go ahead.
The title is AIQ SAR, something about the software. It's, yeah.
Okay, so is there any questions? Okay, Nicoletta, go ahead.
Hi, Christian. Congratulations for the tool and for all the results that you also showed to us. Do you plan to include as well in your tool some sort of techniques based on deep neural networks? Because I saw that it can calculate regressions, binary and multi-class classifications.
Thanks. Interesting question, of course. Neural networks are very cool, and indeed, initially, the way we developed this was to use a lot of models and then to sort of in every progression, in every step, include those that perform the best. And neural networks, one of the neural network models was inside for a long time, and it performed very well, but it was the one that took the longest time to execute. So I think at that time we had like 12 models, and the other 11 took the same amount of time as a neural network. And I'm talking about this all in terms of the default settings that this specific package had. And so idea was either to reduce, let's say, the parameters of neural network and probably therefore reduce performance. But in the end, it behaved comparable to other models, and simply because it took so long, we ended up not having it in the final version.
Thank you.
Is there any other questions? Mark Cronin, yeah, please, Mark. Hi, Mark. How are you?
Hi, Paul. Happy birthday. Hi, Christian. Just did you learn anything about data quality for the LD50 data?
So for the LD50, I assume you mean the initiative from the EPA that was one of the analysis. When we used it for linear regression, we transformed it into logarithm of molecular mass. So we got data. So that is somewhat related to the quality control. We got data as a mass, and then we transform it into molarity and use the logarithmic values, because we noticed that with that transformation, we had much better performance. And in terms of the data set itself, since it was data set released for this initiative, we used all the compounds. We did some QC and we saw like some chemicals that seemed to be outliers, but since this was the data set released to us by outside party, we ended up using all the compounds that were available.
Thanks, Mark. Thanks, Christian. Is there another question? I'm not sure if Emilio's hand is up or not. Is it, Emilio? No. Mariana has a question. Go ahead, Mariana.
Yes, thank you, Christian. Very nice lecture and very nice tutorial also. So this is actually meant also for developers, not just for, let's say, users, normal users that assess chemicals, for example. Do you think that the final model that you get, that a user can get out of it, can it be somehow given to public? Can it be easily incorporated into the Vega, for example, or some other tools?
So for the part about the development, indeed, the main objective of this was to have the system where somebody can build a new model. And this was important because in other way, we could just include more models into Vega, which is also a great thing to do. So the idea with this is once somebody prepares the model, they can use it with AIQ SAR further on. There is no direct way to implement it into some other software, but indeed, this is the objective of this was to have very simple system that would give basic performance. So that would be like the baseline performance from this tool. If somebody would develop new model, can be used as a baseline, and then it can be improved further, of course, with some systems that are not automated, where the user will change some parameters, fine tune something, and then let's say implement it in Vega. So the idea of this is to use it just as a baseline where everything is automated, and then there are many ways to improve it, either with different machine learning or with modifying the parameters and using it in a different software in the end, for sure.
Thanks very much, Mariana. Thanks, Christian. That was really nice. Now, who is the next ESR? Mr. Murphy. So, Cormac, if you could remind people the title of your talk, or something similar to the title of your talk will do as well.
So my talk was on using iPS-derived podocyte-like cells for toxicity testing.
Okay. Is there any questions from the audience? Walter Fowler has the first question. I'm going to spotlight you, Walter. Hang on. Add spotlight. Okay. You're muted, though, Walter.
I can't hear you, Walter. You're muted.
Yeah. So now you can hear me, hopefully.
Yes.
Yeah.
A very nice presentation, Cormac. Congratulations. You showed one slide where you were growing the podocytes, or the supposed podocyte-like cells, in combination with endothelial cells, and you had typically nests of endothelial cells. Have you followed the further differentiation of these positions in order to see how the podocytes, or the podocyte-like cells, interact with the endothelial cells?
I will be honest, Walter, I haven't really gotten a chance to do much more work on the co-culture of those cells this year. That was something that got very much interrupted by the COVID. But and what I found is I was trying to see how, if the endothelial cells, when grown with the podocytes, could survive without their medium, without their additional factors like the added VEGF and etc. The one thing I did found is that the endothelial cells grown in the without their extra factors with the podocytes survived for considerably longer than those grown without podocytes, which all died very, very quickly. But no, I didn't. This was only about an extension of about 5 days, so I didn't get a chance to look at them further than that. Yes.
May I add a second question?
You can, Walter. Yes.
Yep.
Have you ever tried, as far as I understand, you have been growing the podocyte-like cells always on plastic culture tissues.
Mm-hmm.
Have you ever grown the cells on a different extracellular matrix?
Well, I've grown them on. Normally, I grow them on plastic, but on Matrigel. But I have. But actually, we've been working in the group, and we've been tried differentiating, growing them on a number of different extracellular matrices, different commercially available extracellular matrices, and I don't know if is Anya online about how much I'm allowed to talk about this in this case, but we could definitely talk about it afterwards. But I've also grown them on glass and a filter membrane in the organ on a chip that I mentioned, and they seem to survive pretty happily on most things I put them on.
Okay.
Thanks, Walter. Is there any? And Walter, please speak to Cormac later on in the breakout session.
Yeah, I have a few more questions anyway.
Yeah, you should have a proper discussion. Okay. So that's good. Don't forget, write down your questions, Walter. So anybody else in the audience have a question? Well, if there isn't, I will then. But somebody just check if there's any questions. So Cormac, actually, Baz asked Zara an interesting question. With endothelial cells, that they seem to be, there's many different types. So do you see, and a bit of follow-up to Walter's question, do you see any root of the cooperation between the two cells there? I think you know what I mean.
As in how they could be signaling towards to each other to
yeah, is it possible the podocytes could signal the endothelial cells in any way?
Oh no, absolutely. I think that I didn't show it there, but I think I mentioned the talk that my podocytes produce VEGF after day 9 of differentiation, and I think I think I'm sure Zara would correct me if I've read it, but increased VEGF can encourage the fenestration in endothelial cells, which would make them more like which direct them more towards the glomerular endothelial phenotype. So I absolutely think a co-culturing between them, like Zara suggested, could encourage the endothelial cells or iPS-derived endothelial cells to have a more specialized phenotype or characteristic.
Oh, excellent. I think I would have thought the same thing as well. So it's got exciting times to come, I think. Thank you, Cormac. Can we have the next ESO, please?
Anna,
Can I just add something before going to next ESR?
Yes, you can, yeah.
I just want to ask all the ESRs to also check the Slack because I see some questions there. Please, thank you.
But check Slack. Well, not now. After the session, right?
Yeah, 1 hour.
Because you should be listening now and watching. So Anna's next. Anna, can you remind us of the title of your presentation?
Yes. Hi, everyone. My presentation, it was about studying human aromatase enzyme, and I was presented several types of in silico methodologies to do it. So I was mentioning about classification modeling and the derivation of structural alleles. And also I was giving some examples about how read across could be applied. All this.
I just realized we put your video up the latest. So I think you should have the questions later on in the day. So nobody let me forget after people have watched your video, because I don't think anybody's seen your video yet. So I just realized that. So that's just a teaser Anna gave us. So very nice teaser. So don't forget to watch Anna's video, and then you'll take the questions then later. So maybe that's the case with the rest of them. Maybe Sarah and Zara can help me here.
It's missing Anna and Leonie. We should see Leonie's video now.
Okay, so then now we have the privilege and we have the time to watch a live talk it's a recorded talk that we will show live, and it's Leonie's talk. So Carolina, if you can get that operational, that would be cool.
Zara?
Yes.
Or Sarah, please.
Give me a second, please.
Yeah, sure.
And I think this morning we didn't have
the recording for that one.
Oh yeah, stop the recording before you play it, please.
And I think this morning we didn't have the chance to talk about the presentation of Shreya. So also to take into account later.
Oh yeah, Shreya there. We could do Shreya now. Shreya, are you on the line?
Yes, I am. Oh, sorry.
Okay.
I looked
so Shreya, you had. Can you give us the title of your presentation, and then we'll have the question and answer. Don't spotlight Shreya, please. She doesn't have a video on. So Shreya, go ahead.
Oh, well, it was the application of iPSC-derived hepatocyte-like cells to hepatotoxicity testing.
Okay, so any related questions? Just looking at the time, so 14:08. That means you have until 14. My numbers.
Linke had a lot of questions.
Well, I answered all of hers on Slack itself. Because it would take way too long to answer here and nobody else would get the chance.
Exactly. No, but maybe Shreya, just maybe summarize a few, because your answers are really useful. So maybe, I don't know if the others want to see.
Well, we'll see. We'll put them, if it's on Slack, let's keep it on Slack unless we can find it.
Yeah, it's in the, yeah.
It's okay.
If you have a question now, Ninka, a live question, because this is about oral communication. No? No, I don't want to put you on the spot.
The answer to your question.
Okay, put her down if she doesn't have one. Who has a question for Shreya?
You can also just read the Slack.
Yeah,
is it okay if I do
Slack
that?
now. Okay, I have to get control of you rebellious people. So what we're doing now is question and answer sessions, live, communicating. So does anybody have a question for Shreya? Vidya does. So Vidya, please.
Hi Shreya, it was really interesting to see your model, and I was also working with it, and I saw when comparing with other controls of other iPSC derived model, your model seems to outperform very well.
Okay.
And at one point of your presentation, you said your model is still immature. How do you define that model?
Yeah, actually, I would have to direct you to the paper that another PhD student in my lab published this year. So the cells that he has, they're also 3x, like with the 3 transcription factors added to the cell lines. Well, his model is an ESC-based one, but he's also done it in other iPSCs, and in fact, I've also been working with those. So the different characterizations that I've done for the mature hepatocyte markers in RNA level, at protein level, as well as the albumin secretion and the CYP3A4 activity, they're much higher. They're, well, almost comparable to primary hepatocytes, even 0 hour. So, so freshly isolated. So they are definitely better, but this seems to be more of a line dependent thing, because I'm doing exactly the same thing, and it has happened with another iPSC line in our lab as well. So the HLCs derived from it is not as good as in the others. But yeah, that's not really the model. It's more the cell line itself. That's why I say they're not completely there yet. But that's something I think that's the case with all of our models, isn't it? We're not there yet, but hopefully we will be. I have hope.
No, good answer. Thank you, Vidya. Is there any more questions from the audience? I would have one if required. I don't see any. Actually, a bit of a follow-up to Vidya's one, and it's just spontaneous on your answer. So, do you think that's a donor issue, or is it something else?
Well, donor issues definitely could be, because when I first did my experiments before the addition of the cassette, or before any of this was done, when I did the first differentiations with the SBAT3 as well, I noticed there was a significant difference even at RNA level of the hepatocyte markers. So there definitely is donor differences that I can say, yes.
But could it also possibly be because the CRISPR-Cas9 technique is very precise, but it's not yet fully precise?
We haven't used CRISPR-Cas9 for this line. I've used zinc finger nucleases.
Oh, and that's something I know nothing about, so I can't ask you a question about that. Does anybody else have a question for Shreya? It's strange, Shreya, because always it's all about liver. And now you're only one ESR is doing liver, and nobody seems to be interested in the liver, which is a bit unfair.
Oh, Susanna is also working on liver.
Oh, Susanna's also working on liver. Yeah, I just think of kinetics with Susanna for some reason. We still have a few minutes. How are you doing? Ellen has a question. There you go, Ellen.
What Paul just said made me think. So indeed, Vidya also in the TempoSeq experiment compared HepG2 cells. And did you compare your data amongst each?
No, not yet. But I think we didn't really have any compounds in common either with Susanna.
With me, no, because I tested compounds not from the in3. I only
exactly. Yeah,
tested
that's the reason why.
Okay.
The only thing you can compare is if any of the compounds is a PXR or CAR inducer, and or with the controls then.
Well, that's now a topic for a breakout session. Thank you, Shreya.
Yeah, because that's a whole.
Oh, but I do have another question. But
I'm sorry, the time is up for questions. I don't know how many times I asked. Do you have a question? So somebody unspotlight Shreya and